All right, this is the last section in our naming compounds notes. And so now we're going to talk about what happens if you have a polyatomic compound. And so basically, you know you have a polyatomic compound if it contains 3 or more elements. That's the key. So everything that we've dealt with up to this point has basically 2 elements. But now we have 3 or more elements involved. And so the key is that because they have 3 or more elements, you have to look for the polyatomic ion. And that's basically the first rule. So you're going to need those cheat sheets. You're going to look for the polyatomic. Usually it's going to be at the end. You're going to then, therefore, name that ion. And then usually what's left over once you name that ion is a metal. And so since you have a metal left over, we're going to treat these a lot like a type 1 or a type 2. So if it is a type 1, what you're going to do is you're just going to go ahead and name the compound, like name the metal. So sodium or calcium or whatever. But of course, if it's a type 2, you're going to be required to put in that Roman numeral. And so we'll have to figure that out. So some of this should feel really familiar. The only thing we're adding in is the polyatomic ion. So let's look at some examples of that. Okay, here's 2 to start with. Now, something you might add to your cheat sheets that I think is very, very helpful is the fact that if you have a set of parentheses, that is going to be a big indicator to you that you have a polyatomic compound. So you might just take note of that. That parentheses indicate polyatomics. Now, so like for the first example, it should scream at you it has a polyatomic. Besides the fact that you can count and go, okay, 1, 2, 3 elements, okay? So besides the fact that we can count and say 3, the parentheses should tell you that you have a polyatomic. And in fact, the parentheses kind of circle the polyatomic for you, so you don't have to do a lot of looking for what the polyatomic is. I like to box my polyatomic so it's really clear what is the polyatomic, what am I allowed to touch, what am I not allowed to touch, and so it just comes in handy. It's kind of how, I don't know, something that I like to do. So NO3, we should be able to find on our cheat sheets as nitrate. Okay. And then notice that all we have left within this compound is calcium and this 2. Now the 2 won't really matter depending on the metal. Like I don't really care what that 2 is, if it is a 2, based on whatever, you know, if calcium is a metal that I need to write a Roman numeral or not. Well, calcium is always a 2+ charge, which means that all I need to do is go over here to my line and write the word calcium, meaning it does not need a Roman numeral, meaning that there you go, the name is calcium nitrate. Done, finished. Go on to the next, problem. Okay? So in fact, that's what we're going to do. We're going to go to the next problems, PbCO3. I look at it and I say, okay, I got to search for something that is on my polyatomic sheet. CO3 is on my polyatomic sheet. And in fact, and that's why I boxed it, there's a good reason. This is a perfect example of why I wanted to box this. That is the carbonate ion. Now, the reason that I boxed this is so that notice that 3 is inside the box. So the 3 is untouchable. So in fact, you don't do this, but I'm going to do this just for like looking right now. Because the only thing I have left over is this lead. And lead is a metal that I do not know the charge of, which means that if I go over here and write down lead, it's going to require a Roman numeral, which means I'm going to have to figure out the charge. Well, Lead, if I go and do the uncrossing thing, if I didn't box that and kind of take it out, I would be tempted to uncross that 3. But that 3 is part of the polyatomic. So I actually have to go out here and cross it back. And here and cross. Okay? So it appears like both of them are 1s. But what is inside that box there, if I erase it now? Okay, what's inside the box is CO3. And if you look up on your chart, CO3 actually makes a 2 charge. So this was one that was reduced, and so I need to multiply each side by 2 in order to get the correct charge. So the Roman numeral should be a 2, not a 1. So that is probably like kind of one of the more complicated examples because of the fact that you've got to figure out what that Roman numeral is. And you've got to be very careful because there's no parentheses so it doesn't separate it out. Alright, let's do some more examples. Alright, I'm going to save this one for later. We'll have some funsies with it later. Okay, so let's go down here, NaCN. CN should be the part you can find on your polyatomic sheet. That is cyanide. And again, I boxed that. So you can see that the only thing you have left to figure out what it is that Na, which if we go and look on our periodic table, sodium has a 1+ charge, which means that I do not need a Roman numeral, because I can tell you what the charge is just by looking at the periodic table. So the name of this compound is sodium cyanide. Okay, let's try the next one. We look at the next one. You should be able to go to your polyatomic chart, find SO4, which is sulfate. Okay. And then notice all I have left over is again sodium, and we already determined in the last problem that sodium has a 1+ charge. So sodium, no Roman numeral, sulfate. Alright, let's get back up here to the beginning, the one that I skipped. I wanted to do a couple more before I got into this one. Notice that everything we did so far, what you did was you were like, okay, basically the last couple ones were the polyatomics. So you're tempted to box that and look for that on your chart, the H4I. Well, if you start looking for the H4I, you will probably see that it's not on your chart. And there's a good reason for that. The reason for that is because this polyatomic is actually at the front. There is one polyatomic that exists at the front of a compound that we're going to use, and that is NH4. So just be careful if you are having a lot of trouble finding at the end, search for the front, okay? Excuse me. All right, so that's ammonium. And then at the end of the compound, notice we still have the I, which is iodine. But remember that what we did with the endings is that we changed them to iodide. Okay. So this is just the one that's a little different because of the fact that the polyatomic is at the front of the compound. Okay. All right. Now, the other thing I wanted to show you is that don't be afraid. Some of your polyatomics will have more than 2 letters. So far, everything we've had is 2 letters. Look at this one here. This one actually has 3 letters. Sometimes you can have 4 letters. Here's an example of one that is dihydrogen. Phosphate. Okay, and so all you have left over is your potassium. And so you have potassium, which does not require a Roman numeral, and I ran out of room, so that potassium looks horrible, but you get the point. Okay, then you go down to the next one, and look, love parentheses, look at this. because it's boxing it practically for you right now. So we have the nitrate ion. And so all we have left over is Fe, which is iron, and iron I do not know the charge of, which means that I'm going to be required to write a Roman numeral for. So I cross this back, I cross that back, 3, 1. Check your charges. Does NO3 make a 1 charge? Yes, 3, Bob. So that means that your Roman numeral is a 1, 2, and 3. Okay. Then the last one, OH. Okay, so OH, you should be able to find that it's hydroxide. Then what you have left is Mn, which is manganese. And manganese is one of those that requires a Roman numeral. So again, do your uncrossing. The 2 comes up here. The 1 comes up here. And then ask yourself, does OH make a 1 charge? And it does. So your Roman numeral will be a 2. So that's basically polyatomics. It's just like type 1s and 2s, except for you're adding in a polyatomic ion.